Okay, this is the binary shift. Now, this is the May 2018 AQA GCSE Computer Science paper, but the same principles apply no matter what paper it is, what exam board it is, if you're doing binary shift. What you need to remember with this, if I just draw up here, is if I shift to the left, then I'm going to multiply, and if I shift to the right, I divide. It's beautifully simple, this. So this question, this was 3 marks in total. The first question says, what is the result of applying a left binary shift of 2 to this bit pattern? Express your answer as a bit pattern. So here's your bit pattern up here, and what I like to do is just write on there the place values, 64, 1, 2, 8. So that number there, 4 plus 2 is 6. So if I'm shifting left 2 places, then that becomes a 0, that becomes a 0. This is going to go to here, this is going to go to here. I would draw arrows in, but it's just a bit too small to do that, and if I want to I can put the zeros in there as well. Okay, there should be 4 zeros now because there was 5, and there should be 2 zeros there because this is now shifted, and that is now 12, and that's shifted 1 place. I need a shift of 2, so I've got to do that again. So that becomes 1, that becomes, and I've now got 3 zeros there. I'm not going to bother doing the zeros there. You get the idea, okay? 16 plus 8 is 24, and that's my 2 place shift. So what it's asking for is, what is the result as a bit pattern? It is 1 1 0 0 0. That's all you need to write. You do not need to convert it. And you don't even need to do that if you can just do that. Just write it down. But the answer is 24 in denary, or 11000 in binary. Right, question 3.2. The arithmetic effect of applying a left binary shift of 1 to a binary number is to multiply that number by 2. State the arithmetic effect of applying a left binary shift of 3 to a binary number. Now, what this has asked people to do, and what a lot of people didn't do apparently in the exam a year ago, was to actually explain what's happening. They actually did it. They did the shift, and to me that would have taken some doing. It's actually easier just to write out a sentence explaining what that is. But they did all that work and got no marks for it, so that isn't good to do. So to do a shift of 3 is going to multiply the number by 8, and that's all you need to write, and that is 1 mark there. But just to show you how that works, if you're not sure, 1 2 4 8, if I just take the number 1 there, I'm going to run out of space here, but I shift it once, twice, 3 times there, okay, that's 3 times, then I end up with 8. So 1 times 8 is 8. So it's multiplying the number by 8. Write that out if it helps you to do that. But it does ask for a sentence there, so you need to read the question carefully. It does the key word there is state. State the arithmetic effect, not do it, not do a sum. State it. Right, 3.3. What will be the arithmetic effect of left binary shifting a binary number by 4 and then right binary shifting the result by 5? So you shift by 4, multiply by 16, then you shift back again, 1 2 3 4 5. If you just shifted 4 places back to the right, you'd be back to the original number, but if you shift another place, you're going to halve the number. So you go forwards 4 places and then back 5, so you're halving the number, okay? And obviously if that was a 1 to start off with, then you're into remainders there, you've got an overflow, okay? So that is 3 marks there, and that is the binary shift. So just to remind you, just to recap, if I go left I multiply, if I go right I divide. Beautifully simple.